Welcome to chapter 1. This chapter is just an introduction to statistics. So, we're going to cover some things related to how you should approach this course in terms of kind of the psychology or the attitude that you should have. And then we're also going to talk about what this information will get you in the real world. So, jobs you can have with it, how much money can be made, places it's being used, places it's being misused. We're also going to talk about some broad concepts that you'll need to know for this course at the end of the lecture. So just some kind of foundational items that we'll be building upon all semester. So let's dive in. Okay, so the first thing that we need to address is math anxiety, which is a real thing. Real meaning that it's researched and that there's quantitative evidence supporting the idea that it's a significant phenomenon happening. And so I've posted some articles for that in this module. So if you'd like to learn more about math anxiety and get some tips for how to cope with it, you can look into those articles that are posted on the module on Canvas. But I'm also going to give you some tips here. So the first one is I would discourage you from flipping through the text unless you are a person that gets excited by large formulas and Greek symbols. I just wouldn't look at it yet. We're going to be building up to these formulas, and so those Greek symbols will become more familiar to you as the semester goes on, and those formulas won't look so daunting as we kind of build on them. If you just look at them all at once without kind of building up to them, it can be a little intimidating. So I wouldn't do that, but I would familiarize yourself with the index and the glossary, get to know kind of the back of the book where the tables are, as well as where the practice problems are, so that you can utilize those resources. The next tip is forget past math failures. Statistics is different, and it truly is a completely different animal than like algebra or geometry or any other math class you may have taken. In my experience, I found statistics to be different because I was able to take some of the ideas that I was learning in my other psychology and social science classes and apply them using the stats I was learning in my statistics class. So, in other words, there were real world examples, and I understood exactly how I would need to use this math when I became a psychologist. And that was a real gift because it actually allowed me to kind of fall in love with statistics and gain some confidence because I was interested in it. And so, the challenge was kind of easier to embrace than in other past math classes where I just couldn't figure out why I would need this information. And so hopefully I can pass that experience on to you, and you find that statistics is unique, and that it's useful in so many different ways within our lives, but especially as people that are going to be social science majors or any major, really. Okay, so let's just talk about stress and anxiety kind of in general. Um, some anxiety is actually helpful. So we have different types of stress. We have distress that depletes the body when it is happening to us at high intensity or for a long time. Then we can even experience physical problems because of our stress. But then there's also eustress, which is a type of stress that motivates us and helps us to be productive. It's the stress that gets you to go to the dentist. It's the stress that gets you to go to work on time. So a little bit of anxiety is actually going to be helpful. So for further support for that idea, I'm going to show you the Yerkes-Dodson law. This is Yerkes, and this is Dodson, and they created this law in 1908, and the law is that we function at our best when we are at a moderate level of arousal. In other words, moderate levels of arousal lead to optimal performance. So this law has been used in everything from sports psychology to gambling, but we're going to use it in our statistics class to help us kind of harness the power of that good eustress that can create kind of that anxiety at an optimal level for us where we'll be able to really perform at our best. So if you look on the screen here, you can see our curve, and what we have on the x-axis is the level of stress, and then what we have on the y-axis is the performance. So what you can see is that when the level of stress is low, performance is also low. But then as the level of stress increases to a eustress level, we have optimal performance. And then once we get into that distress region there, we start to see our performance go down again, because now we're entering into fatigue, exhaustion, breakdown, burnout, like test anxiety. And so we want to try to stay in the middle of that curve there in the eustress region. Okay, so sometimes students think that since all of the exams and quizzes are open book, open note, all open materials, that they don't need to prepare for the tests. And that is not a good idea whatsoever. You would get into the test, and in most cases, many of you that are unprepared would experience more anxiety. So what you want to do is try to prepare as much as possible for all of the quizzes and exams. There's quiz reviews available, there's TA tutorials available, there's all kinds of resources on Canvas. And so you definitely want to use your resources and be organized when it's time to sit down and take those quizzes. Reach out to the tutors, do everything that you can to be as prepared as possible going into the quiz. And that should help to reduce some of that test anxiety. So do utilize those resources. The next one is think positive. I've heard that some students refer to statistics as sadistics. Hopefully not my students, because hopefully many of you that are my students will kind of accidentally fall in love with statistics, as I did. Some of you won't, and that's okay too. I get that. It's not for everyone. But a lot of people do surprisingly find that they enjoy it, that they like doing it. So just be careful what you tell yourself. Give yourself words of encouragement. You certainly can do this. If I can do this, you can do this. Trust me. It just takes practice. It takes time. It takes work. You got to familiarize your brain with weird Greek symbols and weird equations, and unfamiliarity causes our brain to get a little anxious. So you just kind of have to deal with all of that. But, there's a lot of support for the idea of self-fulfilling prophecies, which is that if you think you can do it, if you think you're going to be successful, you're more likely to move and act in a way that's congruent with that thought, right? So if you think that you're going to do well in statistics, you're more likely to study and work hard and spend the time getting organized and reach out to your peers and go to tutoring than if you sit around telling yourself that you're going to perform poorly and you're not going to do well and you're going to fail the quiz, then you're less likely to take the necessary steps to do well. You're likely to just kind of throw your hands up and say, I can't do it, so I'm not going to study, so on and so forth. So think positive. And like I said, if you can reach out to your peers and get to know someone and kind of have a partner to work on these worksheets with or the homeworks with, that would be great and encouraged. And so there is an icebreaker activity on Canvas. I encourage you to not only do that, but also maybe reach out to some people that you have something in common with, or if you recognize someone from any other classes, reach out to them so that you kind of feel a sense of community and that you're not alone in this statistics struggle. Even in my real life, I spend a lot of time on Stats Twitter and Stats TikTok talking to other statisticians out in the field, and we often kind of commiserate together about challenges that we have with statistics. We talk about how fun it is as well, but sometimes you just have those moments where you just don't understand what you're doing for a second with stats. And I just want you to know that that's normal. We all feel that way, even professionals working out in the field. Sometimes you just feel like you get it, and then other times you don't, and then it comes back to you. Either way, it's all good. You're going to be okay. Here's a TikTok that illustrates that and also introduces you to kind of the stats TikTok world. They're out there on Twitter, on TikTok, on these social media sites, and it's a great way to network and get resources and stuff. So I'll be posting social media accounts of people that are active in the stats field, data science fields. And so if you're interested in those majors or those areas, you can follow those accounts. Sometimes they have internship opportunities, research, all kinds of cool things. So here is the first one. This is data scientist Chelsea Parlett having a stats moment.
I know everything I need to know about you.
You do?
Actually, stats is hard and I feel like I don't know anything.
So I don't want you to feel discouraged. I just want you to be mentally prepared for a challenge, but be open minded to the idea that you might actually enjoy the challenge. All right, so let's talk about what statistics is and also how we can use it. So, statistics is a branch of mathematics that focuses on the organization, analysis, and interpretation of a group of numbers. Our statistics course focuses on social sciences, and so we're going to be interested in the numbers that we get based on research we do on human participants or animal subjects. But the skills that you learn in this class would help you to be on your way to becoming a statistician in any field. Statisticians are everywhere and they contribute to the world in a lot of really beneficial ways. Also, something that's really cool about statistics is that it allows you to ask questions about the world in which you live and then research the answers to those questions yourself. And so you're able to kind of satisfy curiosity. Statistics is fun. People use it to talk about gambling. People use it to talk about sports. People use statistics in a variety of different fields to help people understand what's going on within that field. And then additionally, there is money to be made being a statistician. So there's a high demand for statisticians, and that demand is growing. So I have a chart here for you that kind of shows the average salary based on area for a statistician. You'll have to adjust for inflation since it's from 2015, but it's still going to be relatively accurate. So just a little bit of how you could use the information from this course in a professional way, but also if you look on the screen, there are some uses for this course that have to do with kind of more specific outcomes. So the first one is that after this course, you should be able to read the work of other psychologists. And I would even go as far as to say you should be able to read the work of media journals that present statistics, as well as academic journals that present statistics. Kind of in a basic sense, this is an intro to stats course, so the more complicated multi-models of statistics you'll learn in future classes if you choose to. But this should give you a very basic understanding of stats that will allow you to be able to kind of decipher for yourself if information is being presented accurately by journalists or by the media or not. So I think that's a really cool thing that you get from this. And then also it's going to give you the basis of knowledge that you need to eventually be able to do your own research. I teach research methods classes as well as statistics classes, and so this class kind of bleeds right into research methods. You definitely are going to need the information from this class when you get into a research methods class. And then also, it will help you to hone your own reasoning and intuition and critical thinking skills. Numbers are difficult to dispute because they're concrete and they're tangible, but statistics also has ways of kind of manipulating numbers. And so you have to be a strong critical thinker to be a statistician, and hopefully you'll learn a lot of tricks and skills throughout the semester that will help you to hone your reasoning and intuition skills. So as I mentioned, people manipulate stats all the time. It's not difficult to do. We see people misuse stats in the media quite frequently. Here is a chart from the COVID-19 crisis that the state of Georgia put out. And as you can see on the chart, the numbers on the x-axis are out of order. And they're out of order intentionally to make it look like the numbers are going down. And so it's easy to manipulate graphics for sure. I'll show you some other manipulations of graphics later on. But it's also easy to just interpret the data incorrectly. So one of the ways that happens is called cherry picking, and that's when people take information from research, statistical information that supports kind of their argument or their point of view, but they leave out any information from that research that doesn't support their argument or point of view. During the COVID crisis, we saw this happen when people were arguing that it was safe to take the drug hydroxychloroquine, and that it lowered the death count in people that had COVID. However, when people cited that research, they were cherry picking because they did not include that in that research. It also stated that it could increase deaths in people that had heart conditions, or it could even create heart conditions in people that didn't otherwise have it. And probably the most common misuse of statistics is using correlations to infer causation. So we're going to learn about correlations, but in short, they are a statistical analysis that takes only two variables and looks to see if they are related to one another, not if one causes an effect in the other. But a lot of times researchers will take, or journalists will take correlational research and report it as causal. So, one kind of statistical tale that I've heard for many years is that there were a group of researchers that wanted to kind of trick journalists and show how ridiculous they can be when they take correlational research and present it as causation. So, what they did was they presented this. You can see it on the screen, this graph here called a scatter plot that shows a significant relationship between ice cream sales and murder rates. And they really did the research and they really did find that. And so, what that finding tells us is that as we see the number of ice cream sales increase, we also see the number of murder rates increase. What that does not tell us is that ice cream causes murder. However, a lot of these journalists, as legend has it, cited this research, and even as some even went as far as to post a headline that said, "Ice cream causes murder." So it's important to understand that a correlation is not causation. We'll talk more about that later. But like I said, it's a big misuse of statistics in journalism and media in a lot of different fields. So you'll learn how to kind of recognize that in this course. And also in the module for chapter 1, there is a spreadsheet that has a bunch of different examples of misuses of statistics in real life. If you want to check that out, it's optional. Okay, so you're going to need the worksheet titled Calculator Operations, and we are going to be using that to practice the order of operations. As you see it there on the slide, please excuse my dear Aunt Sally is the acronym, and that stands for parentheses, exponents, multiplication, division, addition, and subtraction. So as a quick reminder, we do parentheses and exponents first. In terms of choosing between which one we're going to do, we always do parentheses first and then exponents. And then in terms of choosing between multiplication and division, we do whichever one comes first, and by first we mean going left to right, whichever one is on the left. And then addition and subtraction, same thing, whichever one comes first, going from left to right. And so then also in this class we have rounding rules, and it's just standard rounding, but it does trip people up, so make sure that you are adhering to these rules. There's going to be 2 exceptions to these rules, one at the beginning of the semester and one towards the end, and I will let you know and sound the alarm when there is a rounding rule exception. But for the most part, this is exactly how you want to round, and you want to make sure that you're doing it accurately because there's no margin of error in Canvas. So what you put in is going to be either correct or incorrect, and if you're off by even a little bit, it's going to count it as wrong. So make sure that you round correctly. And so we, in this class, are going to round to the second digit after the decimal, unless otherwise noted or stated. But in about 99% of the time, we're going to round to the second digit after the decimal. And so if you look on the slide, you see the example there of what we're looking for. So 52.52. That second 52 is rounding to the second digit after the decimal, specifically that 2 there. So you're going to look to the third digit after the decimal to help you decide what to do with the second digit after the decimal. So if the third digit after the decimal is a 4 or lower, you're going to remove it and any numbers after it and leave the second digit as is. So for an example of that, let's say that you calculated 52.524. You're going to look to that 4 to figure out what to do with your second digit after the decimal, which in this case is a 2. So the 4 there means that you are going to just remove it and keep everything as is. So it's just going to be 52.52. And then if the third digit is a 5 or higher, you're going to remove it and any values after it and round the second digit after the decimal up one number. So for an example of that, let's say you calculate 52.525. You have a 5 there in your third digit, and so you're going to be removing it and rounding the second digit after the decimal up one number, which would get you 52.53. And the big one is round at each step of the calculation. So what you need to do is, if you're working through a formula and it has 15 steps in it, you do the one step, you get your value, you round it to 2 digits after the decimal, you clear out your calculator, put the value that's rounded back into your calculator, and then proceed through solving the formula. So I'm going to show you all this now on the calculator operations worksheet. And so for some of you, this is just going to be review. So I don't want you math-minded people to worry. This is not what I meant when I said it's going to be challenging. It'll get harder than this. But we got to start somewhere. Some people, it's been a long time since we picked up a calculator or took a math class. And so this is either going to be like a refresher or a warm-up. But here we go, calculator operations worksheet.
Okay, this is the calculator operations worksheet, and it is going to provide us the opportunity to practice PEMDAS, our order of operations. And so you can refer to the top of the worksheet if you need a reminder, but we do parentheses and exponents first. That's the P and the E in PEMDAS, or the please excuse. And then we do multiplication and division in order from left to right, whichever one comes first. And that represents the my dear part of please excuse my dear Aunt Sally, or the MD in PEMDAS. And then you do the addition and subtraction in order from left to right, whichever one comes first. And so that represents the A and the S in PEMDAS, or the Aunt Sally, and please excuse my dear Aunt Sally. So this is also going to give us an opportunity to practice the rounding rules that we discussed in the lecture video. But we're going to go ahead and start moving through these problems, practicing the order of operations. So the first thing that we're going to do is 25 plus 4 times 20 divided by 2. So we want to do the parentheses first. I don't see any exponents, but there are parentheses, so we'll start with those. So 25 plus 4 is 29. And then we're going to do the next set of parentheses. 20 divided by 2 is 10. And then we'll go ahead and pull down the multiplication symbol, and 29 times 10 is going to equal 290. And then we're ready to move on to the next problem. So this one says 25 plus 4 times 20 divided by 2 equals. And so we would want to refer to our order of operations rules. And it says that we want to do multiplication first before we would do any addition and subtraction, since I don't see any parentheses and exponents. So we're going to do the multiplication first, which is going to be that 4 times 20 portion. So I'm going to just write it out over here so it's real clear. 4 times 20 is going to equal 80. And then after we've done 4 times 20 and we've gotten 80, we're going to take that 80 and we're going to divide it by 2, because if we look at the order of operations, we would want to do the division next before we did any addition or subtraction. So we're going to take the 80 that we got and we're going to divide it by 2. We could do a division sign like a slash, as well as the traditional division symbol. So 80 divided by 2 is going to give us 40. And so then the next step is going to be to add in the missing puzzle piece here, which is going to be the addition of 25. And we're saving that till last because the order of operations tells us to do so. So we are going to have 40 plus 25, and that is going to give us a final answer of 65. Okay, and then the next one that we're going to do is going to require some rounding. So I'm going to get my calculator out for this one to show you how we're going to round. And so first we're going to do the parentheses. And I notice here I have parentheses and brackets. So brackets are treated the same way as parentheses, and you want to start with the innermost parentheses. So we would start with 5 minus 3. So 5 minus 3 is going to be 2. And then after we've done 5 minus 3 equals 2, we're going to add the other portion that's in the parentheses to it. So 2 plus 17 equals 19. And then the only remaining puzzle piece is the 75. So we would do 75 divided by 19. And that is going to give us, this is where our calculator comes into play, 75 divided by 19 equals 3.9473684. So I'm going to look at the third digit here after the decimal, which in this case is a 7. And I'm going to look at that third digit to help me decide what to do with my second digit. So since my third digit is a 5 or higher, it's a 7, I'm going to remove it and all the numbers after it and move my second digit after the decimal up one number. So this then is going to be a 3.95 with correct rounding. So just to show my work, which is always a good thing to do because like I say, we're gonna have problems that take 45 minutes, and sometimes you get to the end and you solve the problem and you realize it's slightly off and it's due to something as simple as rounding. So we want to write down every step so that if we get to the end of a problem and there's an error, we don't have to start all over again. We can just identify the source of the error. So 3.95 is my answer for that one. And then next, we're going to look at the problem that has 54 minus 16 divided by 2 plus 4. And so we want to go ahead and do that division first. So I'm going to do 16 divided by 2, and that is going to give me 8. And then after that, my PEMDAS here says to do addition or subtraction in order from left to right. So whatever comes first. And so in this case, we have addition of 4 and subtraction of 54, and it says to go from left to right, whichever comes first. So the 54 is coming first. So it's kind of like if it's a tie between adding and subtracting, you start with the one on the left. So 54 minus 8 is going to be 46. And then we're just going to complete the formula by adding the 4, and that is going to give us 50 as our final answer. Okay, and then we're going to move on to the next one. 54 minus 16 divided by 2 plus 4. So we want to start with the parentheses first. So 54 minus 16 is 38. And so, you know what, I'm actually just running out of room. I'm going to write it right over here. Okay, 54 minus 16 equals 38. And then we're going to do 38 divided by 2 because we would do division before we would do addition. So 38 divided by 2 equals 19. And then we're going to do 19 plus 4. And 19 plus 4 is 23. Okay, you know what? I'm going to do like a little block and arrow thing here. Okay. All right, and then the last one for this section is 54 minus 16 divided by 2 plus 4. And so we're going to start with the parentheses going from left to right. So 54 minus 16 is 38, and 2 plus 4 is 6. And so then we're just going to pull down this division sign, and that is going to give us, let's go ahead and do that calculation on our calculator so we could practice rounding. Okay, it's going to give us 6.333333. So what I need to do is look at the third digit after the decimal to decide what I'm going to do with my second digit here. And so if my third digit is a 4 or lower, I'm just going to remove it and everything after it and just leave it as it is. So in this case, we have a 3, which is less than a 4. So I'm just going to delete all these other 3s, the third digit after the decimal and on. And my final answer is just going to be 6.33 for that one. Okay, and then we can do the rounding portion down here. And so this is just multiplication, and we're just going to go left to right. we remember that we are rounding to the second digit after the decimal. We look at the third digit to decide what to do with the second. And really important here is round at each step of the calculation, which will require you to input part of the equation, get your answer, clear it out, write your rounded answer down, put your rounded answer back into the calculator, and then continue calculating through the problem. So make sure that you do that, otherwise your answers will be different than the answers that are in Canvas, and so you won't get credit on them if you don't round correctly. So for this first one here, we're going to do multiplication from left to right, and we're going to do 2.37 times 1.67. And when I do that, I get 3.9579. So I'm going to look at the third digit, which in this case is a 7, to decide what to do with my second digit after the decimal. And so the third digit is higher than a 5, so I'm going to remove it and any numbers after it and round my digit that's in the second space after the decimal up one value. So this becomes 3.96. So I'm going to write 3.957 and then a little squiggly equals to show that I've rounded it to 3.96. And then I'm going to multiply that by 0.56. So I have to clear out my calculator and type in my rounded answer and then multiply that by the remaining portion of the formula, which is 0.56. And then that's going to give me an answer that is 2.2176. So again, I look at the third digit. I see that it's higher than a 5. So I'm going to remove it and any values after it and then round up the second digit after the decimal by 1. So my final answer here is going to be 2.22. So I'll write down my unrounded answer just for my own reference. And then I'll put down the correct answer of 2.22. Okay, so then my next problem here is 1.96 times 3.75 divided by 11.92. So we're going to do the portion that's within the parentheses first. And so if I take 3.75 and divide it by 11.92, I'm going to get 0.314. And so what I want to do is look at that third digit after the decimal, which in this case is a 4. And that's going to help me to decide what to do with my second digit. So if it's a 4 or less, I just remove it and leave the rest of that number as is. So my rounded answer for this one is going to be 0.31. So let me put 0.314, and then I'm going to round that to 0.31. So I'm going to take 0.31 and put it back in my calculator, and then I'm going to multiply it by the remaining value of 1.96. And that is going to give me 0.6076. But I'm just going to write down the first 3 because that's all we're going to pay attention to. So 0.607, if I look at that third digit, it's higher than a 5. So I'm going to remove it and round up one value on the second digit after the decimal to 0.61. Okay, and then I am going to do this next problem here. So 2.46 times 7.59 equals 18.671. So 18.671 rounded would just be 18.67 because 1 is less than 5 or less than 4. You know what I'm trying to say. Okay. So then I'm going to clear out my calculator. 18.67 times that remaining value of 0.83 equals 15.496. And so we're going to round that. So 15.496, I'm going to look at that third digit, which is a 6. And so I need to round up my second digit by 1, but I'm at a 9. So that leaves me rounding it up one whole number up to 50. So I'm going to do 15.50. Okay. And then the next one down here, we'll start with the parentheses. This is a pretty long one. Maybe I should write it. I'll write it over here. Okay. So the first thing that we're going to do is 4.24 times 3.67. So when I do 4.24 times 3.67, I get 15, let me write that down, 4.24 times 3.67 is going to give me 15.560. So I'm going to round that to 15.56. And then I'm going to take 15.56 and divide it or multiply it by this remaining value that's in the parentheses, which is 3.01. So I'm going to do 15.56 times 3.01. Let me plug that into my calculator. 15.56 times 3.01 equals 46.835. So I'm going to round that to 46.84 because this third digit is a 5. So that tells me to round the second digit up 1. So now I have 46.84. Okay, and then I also need to get these calculations over here. So now I'm going to do a division next after parentheses and multiplication. So the division is going to be 1.34 divided by 15.64. And that is going to equal, let me write that down, 1.34 divided by 15.64. That is going to equal 0.085. So I would round that to 0.09. Then I'm going to take the 0.09 that I got from doing this portion of the formula, and I'm going to add it to the value I got from doing this portion of the formula. So I'm going to add 0.09 to 46.84. And that is going to give me let me do it on the calculator. 0.09 plus 46.84 gives me 46.93. So that's going to be my answer for this one here. Okay, and then finally we have a problem with exponents. So here we have a squared symbol or a square symbol. And so what we want to do whenever we see a square symbol is we just want to multiply that number by itself. So we're going to do 4.98 times 4.98. If you have the square symbol on your calculator, you could of course do that as well. 24.800 is going to round to 24.80. And we do want to go ahead and put the placeholders in for the second digit after the decimal so that Canvas will recognize our answer as correct. Okay, and then we're going to do 3.36 squared. So 3.36 times 3.36 equals, let's see, plus 1.289. And so 11.289 rounded would be 11.29. And then I'm going to do the last calculation with this exponent here. 9.98 times 9.98 equals 99.60. 99.600. Okay, so that would just round to 99.60. So I'm going to add 24.8 plus 11.29 plus 99.60. Let's see what happens. 24.8 plus 11.29 plus 99.6 equals 135.69. 135.69. Okay, and that is the calculator operations worksheet.
Okay, and so now we're going to move into some basic statistical concepts that you will need to know for the whole semester. And so we're just going to kind of lay these ideas down as foundations, and then we're going to build on top of them all semester long. So there are two broad types of statistics that you'll be learning. The first half of the semester, you're going to learn descriptive statistics, and then the last half of the semester, you're going to learn inferential statistics. Maybe it's like 1/3 descriptive and 2/3 inferential is maybe more accurate. But at any rate, descriptive statistics are statistics that summarize and organize scores from a research study. Basically, they abbreviate, summarize the data that we have. And some descriptive stats include percentage, range, mean, median, mode, standard deviation, variance. You'll be learning those. And so, for example, a descriptive stat would answer the question, what's the average age of students in this class? What you would do is you would go around and you would ask each student what their age is, and then instead of reporting that information as one student at a time, you could quickly report the information by summarizing it using a descriptive stat like an average or a mean, we call it, which is one number that kind of represents the whole data set or the whole body of scores or all the people's ages. So they're called descriptive stats because they describe a body of numbers or a data set or a group of scores, whatever you want to call it. Okay, and then the other broad type of statistics is inferential statistics. And so inferential statistics allow us to draw conclusions and make inferences that go beyond the scores from a research study. In other words, it allows statisticians to generalize what we find in a sample to the whole population. And so we can use just a small amount of data or a small number of people to infer characteristics about a lot of people or a larger group. For example, let's say that we wanted to find out the average age of students at SBVC and see if that age was significantly different from another college's age. We could do an inferential statistic that would allow us to compare those two colleges and see not only if there is a difference between the ages of, or the mean age of the students at the schools, but if that difference is significant. Is it a big difference or not? Is it statistically significant, we say. So, inferential statistics are where we do our hypotheses testing. So we make predictions and we test to see if those predictions are true based on what the data shows us. This can be risky, especially if you use a sample that is not representative of the population, or if you do your stats incorrectly. There could be potentially really negative real-world consequences for incorrect stats done in research. So we want to make sure that when we do inferential statistics, we do it as accurately as possible. However, we also do build into the statistics ways to identify and report any error that we have or that we are expecting because of just like the inherent problems that come with not being able to test everyone in a population. Or making mistakes or not accounting for all variables that need to be tested, things like that. So there's error in inferential stats. We know that. We account for it in our research. It's not a perfect type of statistics in terms of, or it's not a perfect science in terms of predicting or understanding human behavior. We can't say the word prove, for example, when we get our findings. We can just say if there are statistically significant differences or relationships between values, which in our case represent human behaviors, thoughts, feelings, ideas. So why do we even do stats if we can't use the word prove, if we can't say for certain that what we find in our sample is true of a population? Because the predictions that we make using stats are better than just guessing out of thin air, which we would call chance accuracy. And also with statistics and doing research this way, With inferential stats, we know what the limitations are and we acknowledge and report them. So it gives us a lot of information and helps us to better understand the world in which we live. So you're going to be learning a lot of different inferential statistics. They present themselves in the forms of statistical analyses. So they're tests that you will run to test your hypothesis, and they have different names like ANOVA, independent T, Pearson R, chi-square, paired T. These are all different tests that you'll be learning over the course of the semester, and they represent our inferential statistics, but we'll get to those later. Okay, so I mentioned these terms earlier, but just to clarify, you need to have a real strong understanding of what a population and a sample is. A population is the entire group of people or animals in which the researcher is interested in, and a sample is a smaller number of observations that's taken from the total number making up the population. We have to do samples because we can never test an entire population. People don't want to participate in our research, and they don't have to. We can't force them. People are, not of age to participate. They're babies. They can't talk. They're in comas. They're overseas. They don't have a phone, and that's how we're conducting our research. There's all different reasons that not everyone can participate in research, and so instead we have to take a sample, a smaller number of observations, or a smaller number of people from the total number of the population. However, that sample has to be representative, meaning that it has to represent all of the different types of people in terms of socioeconomic status, age, religious affiliation, political affiliation, whatever it is that you're studying. You need to make sure that you are representing all the different ideologies, beliefs, people, characteristics that would be in that population in your sample. Otherwise, what you find from your sample isn't going to be generalizable to the population. It's only going to be true of your sample, and that's just not going to be something that would be considered valid scientifically. Okay, so what I would like for you to take from the last couple slides, the take home, kind of the meat of it, the most important part, is understanding how populations and samples relate to these next two terms you're going to learn, parameters and statistics. So a parameter is any measure obtained by having measured an entire population. And what I mean by measure is a number. So any number, any data point, any data set that is obtained by having measured that entire population. A statistic is any measure, or again, any number obtained by having measured a sample. So when I am measuring a population, the value that I get from doing that, the mean or the standard deviation or whatever it is, the number value that I get from measuring a population is called a parameter. The number value that I get from measuring a sample, and by measuring that could just be giving people a survey and then calculating the average. So however you measure it, if you measure a population, you have a parameter. If you measure a sample, you have a statistic. So that's easy to remember because population and parameter both start with P's, and statistic and sample both start with S's. So make sure you make that association in your mind. Pavlov taught us how to make associations with classical conditioning. He found that most pairing takes about 5 to 6 associations, so we can make 5 associations with parameter and population, and then 5 with statistics and sample by just verbally saying them out loud 5 times. It's weird, but the weirder it is, the more likely you are to remember it. It's only going to get weirder from here. Okay, so population parameter, join me. Population parameter, population parameter, population parameter. Now let's do statistic and sample 5 times. Sample statistic, sample statistic, sample statistic, sample statistic, sample statistic. Good job. Okay, so what is the point of all this? What is the take home? What do I want you to gather from the last 3 slides? Here it is. What's the point? The point is that inferential statistics, remember those are the ones where we're taking what we know from a sample and generalizing to a population, is the technique of predicting unknown parameters of a population. Why are they unknown? Because we can never test an entire population, right? So inferential statistics is the technique of predicting unknown parameters on the basis of known statistics from a sample. So we take what we know from the sample, the values that we get from the sample by doing our statistical tests, those ones I mentioned, Pearson R, ANOVA, chi-square, we do the tests. We choose the test depending on the hypothesis, but we do the right test, and then we get a value, and that value is called a statistic. And then we take that statistic, we generalize it to the population. That value is called a parameter. All right, you made it to the end. Good job. That's all for chapter 1. I will talk to you guys on the next one. Have a good day.